Life on Mars? Well, we don't know for sure, but the scientific community is abuzz with the possibility following the discovery of methane on the planet. And among the many questions NASA's announcement raises is, what do we do now?
We need a way to identify where all of the active vents are, to quantify their principal gases, to identify which might be dominated by biology, if so, which might be dominated by geochemistry.
And I think given the lack of really compelling evidence for deep active fracturing and faulting to keep water-rock reactions going, it's time, it's prudent that we begin to explore Mars, looking for the possibility of a life form that's exhaling methane.
That may change the plans for the next vehicle poised to explore the red planet, the Mars Science Laboratory, or MSL.
We will be launching to Mars in 2011. It is the ultimate mobile laboratory that you wished you had in your chemistry lab in high school.
It combines the concept of a remote automated field lab with the roving capability of its robotic cousins already at work on the planet, Spirit and Opportunity.
What we're doing on the Mars Science Laboratory is we're changing the focus of the science investigation. Whereas Spirit and Opportunity were there primarily to look for evidence of water, which they found, which was great. Mars Science Laboratory is going there to look for evidence of organic matter.
MSL will carry a rich array of a dozen instruments, one of which is an instrument that can actually measure methane in the local Mars atmosphere.
The lab will be powered by a miniature nuclear reactor, which will let it carry more and travel further than any previous rover. But the additional weight of its powertrain and onboard lab will make it much harder to land safely. Spirit and Opportunity used the same basic airbag landing technique developed for the 1997 Mars Pathfinder mission, but the heavy rovers came extremely close to maxing out the system. To get MSL to the surface, engineers have come up with an entirely different approach. This animation depicts the novel sky crane landing.
Instead of putting the rover on top of the landing platform and landing it, we actually turn things around, where we put the propulsion system, the rockets, on, it's kind of like a jetpack, on the back of the rover. And when we come off of the parachute, the rockets in this backpack slow us down. They bring us from about 1 kilometer up in the air down to about 20, 30 meters off the surface of Mars. At that point, as we're still coming down, we lower the rover on these cables. And now we've got this rover with its mobility deployed, basically ready to drive, hanging from ropes off of this rocket platform. And we just continue our descent until the rover touches the ground. The computer on board senses that landing, cuts the ropes, and there you have the rover sitting on the surface, and all we have to do is pop up our antennas and our cameras and drive away.
We're not quite on our way yet. MSL was originally scheduled to launch in fall 2009, but NASA pushed that date back to fall 2011. In a way, that's actually kind of lucky, because with the confirmation of methane on Mars, it gives NASA time to reevaluate the MSL mission, including where it should land.
We have 2 years now with a delay in the launch for that decision to be made. And by then we'll have new data in hand. We hope this will sway the project to consider seriously landing at the event we've identified this week, Nearly Foci.
The landing site, which is defined by multiple scientists, they have been selecting sites, and one of them is Nearly Foci, the region where we see more methane. It's one of the most interesting places on the planet. And it has been ruled out because of the complexity of the landing. But the beauty now is that we had to rethink about it, because that may be a good place to go and look for activity.
The whole point of the Mars Science Lab is to land it at the most compelling place we would dare land a laboratory, an observatory, if you will, on wheels.
The missions that are going to be in the future, MSL, Mars Science Laboratory, and the next orbiter called MAVEN, those missions could be adjusted now. They're still being produced, still being built. They could be adjusted to directly measure methane.
The MAVEN mission to Mars is currently set for 2013.
MAVEN is a mission to understand the long-range history of the Mars atmosphere and provide the context.
It's possible that the MAVEN probe could answer the question, is methane on Mars biological or geological in origin? But that's in the future. Today, scientists are energised by the endless possibilities of methane's presence on the red planet.
There's an energy source for life. That's very exciting, both in terms of the fact that it's active and the fact that it indicates that there could be habitable conditions.
It's very exciting, and it raises the prospect for life very measurably.
One thing is for certain, the planet is active, and it's active right now.
Do I know whether there's life on Mars? No, I can only be hopeful. But I can say this. With all this new evidence, the prospects, the probability of there being something have gone up. And that's what's important. The trend is up, not down. What an exciting time for Mars.
What an exciting time for Mars indeed. We don't know what other secrets the red planet will reveal in the future, but we do know, whatever they are, we will cover them. So be sure to join us for Brink every week and online at sciencechannel.com/Brink. I'm Josh Zepps. Catch you next time.